Oh, hello there, sweetie. This is Mr. Cockburner. Would you like a Werther's original?
All right, just kidding. Today is factoring polynomials, and if you look, it says special cases. This is special cases because it's a shortcut. However, with a shortcut, you need to be paying attention. I've included a quick little checklist for things we need. So quickly sit back, relax, buckle in, and let's ready to go. The objective: factor perfect square trinomials and factor the difference of two squares. So today is the day that we're going to be kind of like, yeah, I did this today, right? I factored perfect square trinomials. That sounds like a very big, bold topic that you learned, and you should be impressed by it. And to be honest with you, you should be impressed because you're doing Algebra 1 at a high level here. So factor the difference of two squares. Again, that sounds like it's regal, right? It sounds like you're doing something that's really impressive. But to be honest with you, it's a shortcut too. So they're quick hits if you're paying attention. All right, so here's the deal. You have the skeleton model right here. And when I was a kid, didn't like these models because I couldn't really read them because they were all letters. So a squared plus 2ab plus b squared equals a plus b times a plus b, or a plus b squared. So this is why we're calling them perfect square trinomials, all right? So if you look, it has a squared on the left, right here, b squared here on the right, and in the middle, it says it's double a times b, all right? So what we're going to do is take the square root of these first and last terms, get that answer, and double it. All right. Down here, if you notice, right here, we have a plus sign. Right here, we have a minus sign. And that's going to be the result of your final answer, whatever that middle term sign is. But the other caveat is right here. Again, you have to pay attention to this kind of stuff. Your C value must be positive. So your last term must be positive every time for this to work. If this term is not positive, it won't work. And if you look here, that's my very first line is the C term must be positive, or your constant term. All right, so here's some examples on the right. You have an x squared plus 6x plus 9. So what they're saying is your final answer is x plus 3 squared. So what we do is this term positive? Check. Square root the first term. What's the square root? What times itself gets you x squared? Well, that's going to get you your x and your x. What's the square root of 9? So we're going to go into Desmos and just make sure if you have to check it. Check it. The square root of 9 is 3. So we have our 3's in the back. And then what's our middle term sign? Plus. So that's why this is a positive. So if you notice, I'll erase my work here. You have the same thing written twice. So nice, you wrote it twice. Well, guess what? As mathematicians, we are intelligently lazy. If you have the same base twice, we write it as an exponent. So it's a perfect square trinomial because these two lengths and widths, let's say, are the same anyways. So if you have the same length and width, it's a square. So it's a perfect square trinomial, all right? And the key, the thing that I need to bring to your attention is right here. Multiply the two terms and then double it. So what we're going to do is when we said the square root of x squared is x, the square root of 9 is 3, we have to double that. What's 2 times 3? 6x. If you notice, that is also my middle term here, right? So that's why this is a 2 right here in that skeleton model, is because we're doubling whatever we take the square root of in the first term, the square root of the last term. We multiply those two together, and we double it to get the middle term. So let's look at the other one. Here we have x squared, and we already know that's going to work because we had this x squared on the first example. 1 is a number that can always be square rooted. 1 times 1 is 1. So now when I take the square root of x squared, I get x. When I take the square root of 1, I get 1. Double it. 2 times x is 2x, which is that middle term. All right, so you know how this is going to work. My middle term is negative, so that's why this is negative. My answers were x and 1, so that's why they're going here and here. 1 and 1, and we take the middle sign. All right, so let's look at this. 81x squared plus 90x plus 25. The reason why I want you to learn this is because it's a shortcut. 81, if we do it this way, the AC, the big X method, we're going to have 81x here and 81x here, right? What multiplies to 81 times 25 and then adds to 90? This number is going to be huge. What is 81 times 5? 81 times, 25 is 2025. So I'm at 2025, and there are going to be a lot of factor friends there. So the reason why I want you to learn this is because when the numbers are big, this is what we want you to try to do, is try to use this little cheat mode. All right? So let's look at this. C term must be positive. Is this term positive? Check. All right? Square root the first term. Square root the second term. What is the square root of, what is the square root of 81x squared? That gets me 9x. What's the square root of 25? 5. So I did that step. Multiply these two together, I get 45x. And then I'm going to do what with it? Double it. Multiply by 2, I get 90x. Is that my middle term? Show is. All right. So then we know that this is what? If it check marks all this, it's a perfect square trinomial. So it takes the middle term sign. What's my middle term sign? Is plus. So this is a perfect square trinomial. I'm going to take this answer here from my front term, this answer here from my back term. 9x is the front term. That last term is 5, and we have a perfect square trinomial of 9x plus 5 squared. Or if we broke it down, I'm just too lazy to do this. I won't do it again. This is the expanded form of that. All right? So these are really quick problems if you know what to look for. Again, we have that on the top right there. C term must be positive. Is my C term positive? Check. Square root the first term. What is the square root of 36x? It's 6x. All right? What's the square root of my third term? What's the square root of 14? If I type in square root of 14, is that a nice, pretty number? No. That is an irrational number, 3.7416573867. So this, guess what, is not a special case, meaning this might factor down with the big X method, or best case scenario is this is as simple as it gets. It's going to stay a trinomial, all right? So this one is not a perfect square because trinomial, because that 14 is not a perfect square. C term must be positive. Check. Right here. Square root of the first term. Boom. 16x squared. Square root of 16 is 4. Square root of x squared is x. And that's going to be my first part that I'm going to double here. What's the square root of 9? 3. So now what do I do with parentheses? Multiply the two terms. I get 12x. And now I'm going to double it, so multiply it by 2. What's 2 times 12 is 24x. That should give me my middle term, my MT. Is that my middle term? Is 24x my middle term? Yep. So I'm going to take that sign and get 4x. My minus sign is my middle term. And my 9 turned into a 3 when I square rooted it. And then I just square it. So, of course, this passes all the check marks. My middle term is 24x. My middle term is 24x. That sign is just going to be put into the parentheses. So I know it says negative 24x. That's why I kind of paused. And I go, no, silly goose. That just goes in the parentheses. All right? So again, this is a perfect square trinomial because it meets all of the criteria that's up here. So I can put that negative sign here. Next example, is C positive? Check right here. It's quick, right? Square root the first term, 3x. Perfect. Square root the second term, 2. Right? The square root of 4 is 2. What is 3 times 2? X is tagging along. I need to double it now. What's 2 times 6? 12x. This should be my middle term. Is 12x my middle? What the heck? Guess why? It's not a perfect square trinomial. It broke down into the very, very last step when I have to double it. It didn't work. So guess what? Not a perfect square trinomial. All right? It's really quick, especially if you know your square roots. I'm going to include a square root list in our class just to give you a quick look of it. Or, again, you got your bestie right here in Desmos. All right? So that is not a perfect square trinomial. This might break down into 2 binomials, or it's just simplified as 9x squared minus 6x plus 4. The second objective for today was a difference of squares, and this one's a little bit easier to spot because there's only 2 terms, all right? So there's only 2 terms. It has to be a subtraction sign, and you have to have even exponents. So these are a little bit more obvious and a little bit more clear cut. And those are going to be in our slides too when we go to the next slide. But if you notice, what's cool about this is you don't have a middle term. You don't have an x term here. So if you look here at the example, we're missing, we have an x squared, the quadratic term, and then we have a negative 9 as our constant. All right, we're missing a middle term. The reason why we're missing the middle term is because if you look at this broken down into 2 binomials, when you do the factoring, you get double distribute, the DDP, x squared, go deep, you get negative 3x. Underneath your double distribute, you get positive 3x, and you get negative 9. When you combine like terms here, it drops out. Negative 3 plus 3, or 3x minus 3x gets you 0 x's, or just 2 terms left, your quadratic term and your constant term. So if you notice, this combination is what's going to happen with a plus minus in your answer. All right? So give me a problem. All right, sounds good. Here it is. First, how many terms are there? There are 2 terms. I'm going to move this over just a little bit. 2 terms, check. Subtraction sign, check, right? Even exponents, doop, doop, check. Square root the first term. What is the square root of 9x squared? We've seen this before. Good. 3x. What is the square root of the second term? What's the square root of 144? Does anyone know? Come on, think about it. Oh, I heard it in the back there. 12. And then what's the square root of y to the 4th? So y squared times y squared gets you y to the 4th. So my base there is y squared. And that's it. These are going to be what I put into my parentheses. Remember, it's a plus minus combo to get that middle term to drop out. So I just put the first term in the first spots, and then the last term in the last spots. They're quick. They're easy. If you want to double check, do that DDP, do the box method, whatever works, whatever tickles the old fancy there. All right. Here, again, I'm going to move this for a quick second. 2 terms. Do we have 2 terms? 1, 2. Boom. Check. Do we have a subtraction sign? Check. Do we have even exponents? 2 and 2. Those are both even. Let's square root the first term. 30x squared, square rooted. If I don't know if 30 is a square root, I go here. 30. Oops. Square root button first, silly goose. 30. And guess what? It is not a perfect square. So guess what this is not? It's not a perfect square trinomial, and this is going to be the simplest form, is that binomial. All right, today was a quick lesson, so I'm hoping you're happy about that. However, it's a lot of recognition, okay? You need to know your pretty numbers. Your 1, your 4, your 9, your 16, your 25. In fact, here's what I'm going to do real quick. What am I doing right now? I'm counting, right? I'm just going to stop at 15. All I did was write numbers 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 15, right? Now watch what I do. I put little squares there. This is going to create my own list of perfect squares. And yes, I know we can go higher, up to 20, 25. I'm just going to go up to 15 right now. What is 1 times 1? 1. What is 2 times 2? 4. What is 3 times 3? 9. What is 4 times 4? 16. What is 5 times 5? 25. What is 6 times 6? 36. What is 7 times 7? 49. What is 8 times 8? 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. I always remember it because it's the opposite of 13 squared as far as the last two numbers get reversed, not opposites, I guess. 15 times 15 is 225. So you are looking for these pretty numbers for these special cases, all right? If the numbers are big, I would always try to do a special case, depending on if it's 3 terms or 2 terms, is a perfect square trinomial with 3 terms, or a difference of squares if it's only 2 terms, all right? So again, I hope you love this video. Again, subscribe, like, and if you have questions, you know what to do. Email, ask them in class, screenshot them, send us those in an email. We can share our screens. But there is always room to help you, and we are always here to help you. All right? Other than that,
I hope you have a good day.
here we go, brownies. Here we go.